So, as we saw, estimating market risk premium, which is like estimating a mean, is very difficult when there is a lot of volatility. So, we saw that for the market as a whole, the standard deviation is 20% a year. Even with 100 years of observations, if I take the mean of 100 years, the standard error that I'm getting, standard error, is 20% divided by square root of 100. So that's 2%, which is very large. Now you might say, I have an idea. Instead of giving you observation per year, how about if I give you more frequent observations? That is, I tell you what the return was every month. Because if I tell you every month, I increase the number of observations from 100 to 100 times 12. Is that going to help? Because that's what a monthly observation is going to give me. Well, let's check it out. Now we have 100 times 12 observations. If the S&P 500 standard deviation is 20% a year, what would be per month? Monthly standard deviation is going to be 20% divided by square root of 12. Why? Because returns are independent month to month. So yearly variance, sigma square per year, is going to be 12 times sigma square per month. So sigma m then is just sigma per year divided by square root of 12. So that's what monthly observation gives me. And now I've got more observations. So what is the standard error now? Well, let's look at the standard error. Standard error now becomes 20% divided by square root of 12. That's what the monthly standard error is. But now I've got 100, I got times 12 observations. So that is nothing but 2% divided by 12, and then I got a square root of 12 here and a square root of 12, so that's why I got a 12 here, times the square root of 100. So that's what the standard error is going to be per month, except that this was supposed to be 20%, not 10. 20% divided by 10. So that was 2% divided by 12. That's what the standard error is going to be for a monthly observations. So I'm saying if I calculate the mean per month is going to be what? Our 8% was a yearly mean. So per month it's going to be 8% divided by 12. Then I got plus or minus 2 times standard deviation. 2% divided by 12. So that's what a monthly mean confidence interval is going to look like. But I still want to know what the confidence interval is for the entire year, not just per month. So I need to multiply that by 12. And when I do that, I'm back to square one. Even though I gave you monthly observations, calculating what the mean is going to be still has plus or minus 4% when I go down to per year observations. So more frequent observations don't really help, when I'm trying to calculate the mean. That's because, you see, mean only wants to know where did you start and where did you end. Knowing how you got there from one place to the other month by month doesn't really change that. You still get to the same level. So taking the data and splitting it more finely doesn't really help when it comes to estimating the means. Now, you're going to see that that's not the same case with measuring or estimating standard deviations, variances, or covariances. There, getting more frequent observations is helpful. Okay?